For 7.5, we're going over how to graph absolute values and quadratics in vertex form. I'm going to, instead of calculating it, I'm going to use a pattern. If I take the vertex out, it would be at +1, -4. Because of the absolute value bars, I know it should make a V shape, and I look for the slope. No number in front, so my slope would be 1. Oh, that's a little out of focus. There we go. So I'd go up 1 over 1, up 1 over 1, and then it would create my V with a slope of 1. Vertex, +3, +2. I look for the slope. There's no number, so it's going to be up 1 over 1 in both directions. I write my vertex. There's no number in here, so 0, +3. I look for my slope in front. There's no number, so it's just up 1 over 1 in both directions. Whoops. And there's straight lines in both directions. Vertex would be -2, 0, because there's no number out here. I look for my slope. Ooh, it's a negative. -1. So I'm going to go down 1 in both directions. Oops, I got off on my corners a little bit. Sorry. I want my vertex, +3, 0. I look for my slope, -2. So I'm going to go down 2 over 1 in both directions. Vertex, +1, +2. Look at my slope. It's a +2 this time, so up 2 over 1 in both directions. Okay, those are absolute value bars, so absolute values create V's. Then we have parentheses squared. So as soon as you see the parentheses squared is going to make a parabola. It'll make a U shape. So I'm going to use this similar pattern. My vertex is at -2, -4. Then you can make a table on your calculator. Totally works. There is a pattern that quadratics follow. They follow odd numbers, so like 1, 3, 5, 7, 9. They take like steps, like a step 1, step 3, 5, 7, by odd values. So when I look at the front, it's just a 1. There's no number there. So I would go by 1, 3, 5. So I go up 1 over 1, 1, 2, 3, up 1, up 3. And it's just like a step pattern. You do not have to use this. I like it. I think it's kind of fun. But you count up from your point. So I count up 1, and then once I take that first step, I then count up 3. And then from that next one, I count up 5. 1, 3, 5, and you go in both directions. Okay, so vertex, -1, -3. Then usually I use 1, 3, 5 when I look at the front, there's a -2, which would make these 5 times -2 is -10, 3 times -6, 2 -2. So I would go down 2, click, down 6, click. Then I repeat, down 2, down 6. Vertex, -4 up 3. Then I usually use, but my one here says that it's going down. So then I'd be a -5, -3, -1. So I'd go down 1, down 3, down 1, down 3, vertex would be at +4, -1. Then when I fix my rate of change, it says it's a 2. So 5 times 2 is 10, 6, 2, and it's a +2. So up 2, 1, 2, 3, 4, 5, 6. Up 2, up 6. Oops. So these numbers don't represent like the number on the side. They represent like counting. So count 1, 2 boxes, then count 6 boxes to fill in. Okay, we have 2 ACT questions. The graph of x squared minus 1 is shown in the standard xy coordinate plane below. For which of the following equations is the graph of the parabola shifted 2 units to the right and 2 units up? Okay, there's my new graph. The vertex would now be at 2, 1, and the slope's going up. So I would write y equals x minus 2 squared plus 1. X minus 2 squared plus 1. Okay, figure 1 below shows the graph of y equals x squared in standard xy coordinate plane. Which of the following is the equation for the graph of figure 2? Oh, they even told me my vertex. That's nice. Y equals x plus 4 squared plus 1. Plus 4 squared plus 1. There you go. See? ACT questions aren't that bad always. If you have questions, let me know. Your next class, you'll be taking a test.